So let me check with you. Does this feel like something that you like how it looks, or do you think a change in perspective might help?
A change of perspective, because
Okay,
I
then
felt it.
then then what we can do even before you go about doing any tips or tricks or trying or whatever is just read it and write it a different way. So when you
Oh,
say 1 divided by x to the 7 or x plus 7, right?
mm-hmm.
Instead of saying all over, that's a description of the appearance. That's not the operation. What's the actual all over thing here mean?
Divide.
It means divide. So sometimes it helps to take statements like this that are just so crunched and just write them with what they actually mean.
That opens the brain.
Doesn't that look a lot better?
Yeah.
But all we did, like all you did was capture the meaning and you got away from the symbols. So again, another reason why I don't like rules, because rules would say maybe we have to work within this, and I don't want to. I'd rather just change it to the same meaning, different appearance. What do you want to do from here?
Um, you can factor the x squared plus 49.
Okay, let's do that.
It'd be x plus 7, x minus 7. Or x, actually, it'd be x plus 7, x plus 7.
How do you know?
Um, Factor for you.
Show me. Show me how you factored it.
Uh, x, x, x plus, wait, x times x is x squared. X, wait, then it'd be 7x, and then 7x is.
Yeah, this is one of those traps. You can think of this one if you want to like avoid the trap. This is called a sum of squares. Sum of squares does not factor nicely. But a nice way that I kind of keep from trying to do that is I'm always in my head doing a quick little guess and check with that 4 square. And I'm saying, okay, if there's an x squared here and there's a 49 here, what has to go where? Like this has to be your 7, this has to be your 7, this has to be x, this has to be x.
Right. And then it'd be 7x and 7x. That's still gonna be 14.
Mm-hmm. So what you're noticing here is a thing to kind of be aware of. Not everything can factor, right? And this is kind of
Mhm.
a tie-in that like what we're playing with here again is nothing more than a number, right?
Mhm.
And you're trying to write it as a multiplication statement. Well, if I gave you other numbers, sometimes you can't write those as multiplication statements either. Like try to factor 17.
Okay.
There's not a way you can change this besides just leaving the appearance alone and saying that there's one of them. Like, but that's not helpful to us. The same thing happens when you have variables. There are some statements that, as they look, you just can't write them as multiplication statements, at least not without getting into some crazy. So this one I think is just kind of locked. We've got to leave it alone, just like we would leave alone a 17.
Hmm. Okay.
But that's okay. If we recognize that we can't do that, we could just as well relate this entire problem like we would want to do with 17. So maybe we do like, imagine that I gave you this problem instead, 1/3 divided by 1/17. What would you do?
Um, you can flip it and multiply.
That's all that you need to do for this one too. As we can look at this instead of saying dividing by a fraction, that's multiplying by the reciprocal. And from there, you can do what?
Um, can you cross multiply?
Okay, now avoid cross multiply. I do not teach cross multiply because it's a rule and I hate rules. Here specifically, I hate it because people misuse it all the time. Let me show you what cross multiplying is for. Cross multiplying is for when you have something like 1 over x equals 1/5. If you go across an equals sign, that is where everyone was taught about cross multiplication. Okay?
Mhm.
And people say, okay, well, that gets you 1 times 5 is 5, and 1 times x is x, so x must be 5, which makes sense because sure enough, this needs to look like the thing on the other side. So x being 5 makes sense to me. Like, this is where cross multiplication happens, but this is actually not a math thing. This is a shortcut. There's no logic here. as it stands. What really people are doing when they cross multiply is they should be taking the time to say, I have an x on the bottom and I don't like it there. I can do the opposite, which is multiply by x. And then I can say, okay, I have a 5 on the bottom that I really don't like being there. I want to get rid of the 5 on the bottom, so let's just multiply by 5. And sure enough, you'll get x equals 5. Like what you do when you cross multiply is you do all of the steps at once. But the reason I don't like it is because you're right, visually, it looks like you should be able to do that here. But you can't because there's not an equal sign.
Right.
And so I don't like teaching that as a rule because people forget about all of the if, ands, and whens that go along with that rule, and they just try using it whenever they see two fractions. So instead, let's just think about them in terms of a story. Here you have one thing on the numerator. Does that mean multiplication or division?
Division.
On the numerator?
Oh, no, multiplication.
Right. Like if I say 2/3, that means I have two things that are each 1/3, right?
Yeah.
So the top means that you have multiplication. And over here you have something on the numerator that has multiplication. So let's just multiply them.
Okay.
What is 1 times something?
Itself, so it'll be x squared plus 49.
Yep, x squared plus 49. So the story just says if I have multiplication and a multiplication, let's just multiply them. And if I have x plus 7 on the denominator, that means what?
You basically multiply itself.
And you multiply that thing times 1 as well. Yep. And so this is where you get to. As we get to this part, it looks like we should be able to go further, but remember you already checked to see that the top can't factor. So even though we might want to try to write this more simply, I don't think we can.